Okay, so you guys had a few minutes to work on this one. The domain. The domain, I really can't even start until I factor this thing. So I'm going to factor the top 2x plus 2 and the bottom x and x. And then to get a 16, it's probably an 8 and a 2 because that also has a difference of a 6. So I'm going to use an 8 and a 2. And then I got to figure out which one do I want to be the negative one. Well, I want the inside to be negative, so I want the bigger one to be negative. Negative, positive. You go outside and inside. Does that really make negative 6x? Yes, it does. So there, it's all factored. Now I cancel that. And that means there was a hole, because the fact that there's 2, 1 on top, 1 on the bottom, means there's a hole at negative 2. But if all you put was negative 2, you would lose half the credit, because negative 2 is the beginning of the hole, and then the rest of the hole is where you take that negative 2 and you stick it back into the remaining equation. What remains after this and this cancels is y equals, f of x is the same as y, equals 2 over x minus 8. Right? So then what I do is I take this negative 2 here and I put it in there. Oh, wait, not the 2. Sorry. I put it in there. And now I'll have 2 over negative 10, which is negative 2/10, which reduces to negative 1/5. They said 2/10. That's fine. Don't mark it wrong for that. 2/10 or 1/5. And it's negative. Any questions about that? A lot of people are going to make a little mistake on that second part. What? 2 and not even negative 2? Okay, negative 2 they get half for. The other half the point is for this part. Yes? How do you get that 1/5? And this is important, because just for perspective, how many of you had to mark the 1/5 wrong? Your person screwed up the second part of it. And that's like a third of the class. Here's what you do. You take what's left. Don't talk now, please. You take what's left after you've canceled stuff. That canceled, that canceled. You take what's left here. That's your new function. And you put the number, this part, into there. All right. So then you get a new number based on that. So I take 2 over negative 2 minus 8. And that makes 2 over negative 10, which makes negative 1/5. All right. That's how you do the more difficult part of the whole. Now, let's do the horizontal and the vertical asymptotes. The horizontal and the verticals, you should do after you've done that canceling thing. So what we had left again was 2 over x plus, was it x minus 8 or x plus 8? Minus 8, that's right. X minus 8. That's what's left after things canceled. And now I look at that and I say, is it bigger on bottom, bigger on top, or same on both? Bigger on bottom. What's the rule for the horizontals? That's the one where Bob tells you the answer. The bigger on bottom, what's the rule for that again? Yes? Whatever's on the outside. And what if there is nothing on the outside? Then you put what? 0, y equals 0. Okay. The vertical asymptote is whatever makes the bottom part 0 after you've canceled stuff. Okay, this is really important. I don't think a lot of people actually write down the new function after they've canceled stuff. And you use it a lot, really. For the verticals, you use that to say what would make the bottom 0. 8. So x equals 8. All right. Now, the domain is what crashes my function, and it's both the whole and the vertical asymptote. And the whole was, again, at negative 2 comma negative 1/5. I think. Was it negative 2 or 2? Negative 2? Okay. So then the domain is all real numbers except x cannot be the whole, negative 2, and x cannot be the vertical asymptote, 8. Why don't I include the y thing? Because notice, these are all x things. Domain is about x's. All right, so there we go. There's the domain. Now for the picture. If I were to draw this picture, I would start with the asymptotes. There's a vertical asymptote as x equals 8. That's way over here off the screen, unfortunately. And then there's a horizontal asymptote at y equals 0, and that's like this. And then it's one of those kind of butterfly type things that's been moved over 8. So basically it looks something like that. I can't draw the rest of it over there. Okay? So now I want you to, oh, yep, you're right. There's a hole at negative 2 comma negative 1/5. So that would be, where if I extend this over farther, -2 comma -1/5, there'd be a hole like right there as it goes across. Yeah. That's just eyeballing it. Yes, that's a good idea. Yes. Plane 2. Okay. This part right here, the 2 means it's going to be a stretch. And you're really not even going to notice that on a graph like this and the butterfly ones. You won't even notice that they've been stretched. So don't worry too much about that. Now, if you needed exact points, remember my advice? XY chart works for everything. You can always take your numbers, stick them into this XY chart. So if I stick in like an 8 for X, I realize that, wait a minute, I have an 8 minus 8 is a 0 on the bottom. That's an asymptote. If I have a 7 here, then I'd have -2. If I stick a 7 here, see, it'd be 2 over -1, which makes -2. And if I put in like a, how about a 0? 0 is always a good number to test. Then I'd have 2 over -8, which is -1/4. And all those points should be on my graph. Okay, 8 comma 1, it's off. It's hard to tell. It's like over there somewhere. 7, -2, also off the graph. 0, -1/4, at least that's on the graph. It's like right about there. Okay. All right. So there's some advice. I figured you'd learn something from it, and give them a score out of 5. 1 for each of these, plus the graph makes the 5th point. Point, and then the graph. And if they forgot the hole on the graph like I did, take off a half a point. Okay, get back to your own spot and see how you did. If you have some wrong, as long as you understand what you did wrong, then we're okay. But if you don't know what you did, then that's where you're in trouble. Yes, ma'am. Yes. Come on up. Actually, there's one sitting on the back wall back there. Pull out the white cord and bring me the cords. I'll show you how it works. That part I need. This part you just make sure that's pressed, which it already is, and then it should just plug it into your iPad and it should work. Yep. All right. So now, how many of you got a 5 out of 5? You knew everything. Wow, that's way better than last hour. That's amazing. How about, how many of you got a 4.5 or a 4? Also very respectable. Just not perfect. Okay. Now, if you had a lot of things that were wrong, you need to study a lot. But we're going to learn some stuff right now, too. All right. This one. One thing at a time. Start with the domain. The domain means all real numbers except what? What is not okay in this? Domain starts with all reals. And then x is not equal to something. It's very rare that we give you one where just everything works. There's usually something that would mess it up. What would mess this one up? There we go. Good. The verticals. I'm going to give you a dumb little ways to remember this, but they sometimes help. If I make my vertical V with a couple of lines like this, do you see how it would be very easy to make that into an X? Because verticals are X things. Therefore, if verticals are X things, the horizontals must be the other things, which are what? Y things. All right, and who tells you why? Bob tells you why. Is this bigger on bottom, bigger on top, same on both? It's bigger on bottom, and this is a good moment where we want to understand that y equals 0 is not the answer. A lot of people just have it stuck in their head that Bob is a 0. No, Bob is an outsider. So, he's, yes. Bob, in this case, being an outsider, means y equals 3. If you want another way to remember horizontals, horizontals is spelled with an H. A small h looks like that, and which coincidentally can be rotated into a y. See? So, just giving you lots of dumb ways. Some of them might stick in your head. Because if you confuse your x and your y and get them reversed, then that's also going to mess up your domain. And then all of a sudden you got half the problem wrong. Okay, so you got to make sure you understand which ones are x's and which ones are y's. And it's also confusing because, you know, vertical seems like up and down, which seems like y. But the verticals are the x things. So anyway, last thing is the hole. Does this one even have a hole? It does not, because there's nothing on the top and bottom that cancels. So I say no. All right, did you have a question? The vertical asymptote is whatever makes my function not work. So you can look at your domain to figure that out. 4 would make it not work. So there's a vertical at 4. All right, so vertical are about denominators. And I recommend you start from the bottom up. If you notice there's no hole right away, you can say none. You got one of your points locked in. And then you move up and say, okay, where are the horizontal and verticals? Bob will tell me some of that. And the verticals are whatever's left after the hole is canceled. And there's something left there. 4 could cause a problem, so you have a 4 for the verticals. And your domain is all the things that could make it have a problem, holes and asymptotes. This one doesn't have any holes, so it's just the asymptote. All right, then lastly is the graph. How do I do the graph? I would start by making the asymptotes go on the graph. And x equals 4. Here's a spot where x equals 4. And then from there, I bet you most of you are smart enough to not make it a cross line. It's an up and down line. It doesn't make any sense to go the other way. If you do y equals 3, find a spot where y is 3. That's a spot where y is 3. Do you get how going up and down wouldn't make any sense in that case? Because otherwise, why not have put a spot at 2, you know? It's not an up and down line, it's a this way line. So now I got my 2 asymptotes in there. And now I can graph my little butterfly thing. And it looks like the key point you're looking for is that one and that one. And then you just closer and closer and never touch in both ways. Like that. Probably could extend this asymptote outline a little bit there. Okay? Any questions on that one? All right, let's do another practice problem. This one's a little different. It's asking you, if you have asymptote lines here, what would the function look like? You can use logic and say, oh, if it's an x equals line, is that the horizontal or the vertical? Okay, those are vertical things. Or they could be holes too, right? Except, wait a minute, it says they're asymptotes. So if they're asymptotes at the 4 and the -2, okay, moving on. All right, so the asymptotes being 4 and -2 tells me I need these things. The bottom is what it's all about here. X minus 4 and x plus 2. And now, how on earth can I get this? This must have not been a bigger on top. Remember the rule for bots? There are no bots. So it wasn't a bigger on top. It's got to either be a Bob, bigger on the bottom. What would the rule for bigger on the bottom be again? Bob? Outside. So you could put this plus 4/3. That would work. Okay. Or we could say it was the same on both. First of all, I'd have to make it really be same on both. So this is this x squared on the bottom, so I could put like that. Now it's actually same on both, right? So if it's same on both, how do I make the answer come out 4/3? Put a 4 there, and maybe a 3 on there. Okay. Or the outside, either way. If I'd have put this 3 out here, that'd have been fine too. Yep, since if you make it bigger on the bottom, by making this top be like a, I don't know, 2 or just an x, whatever, then it's bigger on the bottom, and you go to the outside, and you can make the outside 4/3. Yeah, that works. All right. Here's one. Write an equation for this graph. Give this one a shot. You have these kinds of questions on the test. You know, it's always fractions. That's the whole point of this unit, is rational equations, which are fractions. So it's a big fraction equation. It's obviously got a hole, but some of you are going to obsess about that hole too much. Just ignore it to start with. First thing you got to figure out is, what would the general graph look like? Then you can go back and put the hole in. If it's bigger on the bottom, it would be what's on the outside. But right, you shouldn't be thinking about that right now, though. You should be just thinking, this is a butterfly thing, right? And it's been moved where? Left 2 and so make one like that. Good. This is the parent of it, right? 1 over x. And it's been moved left 2. How do I do that? Plus 2. And then how about the up 4 part? Oh, I'm sorry. Let me sit for it. I just assume. Yep. Yep, the asymptote line. All right. So is this one bigger on top, bigger on bottom, or same on both? Bigger on the bottom. So it's a bob, and so if you looked at the y equals thing, you'd say y equals 3. And that matches up with this, doesn't it? And then how about the x, the vertical asymptote? That's what makes the bottom 0. Is that matching up? Yeah. I don't think it's best to start with that, though. I think it's best to kind of use that to check your answer. To start with, I'd just say, well, I know what this shape is. It's one of those. It's just been moved. Which way was it moved? 2 to the left. And it's also been moved up 3. Okay. So now we're not done yet, though, right? This is the answer so far. And now it's the final answer. Well, you got to have that hole in there. Where is the hole? Where x is not 1, x is -1. So then you just automatically can go put in a set of parentheses like this. And what would you have to put in there? X plus 1. Last thing is, I would need a set of parentheses right here. It's a small thing, but it's an important thing. Because otherwise, only the 2 would be being multiplied by this. And that isn't really what's happening. We want it to be able to cancel. To have it be able to cancel, you need parentheses here too. Yes? Nope. The 1's kind of becomes irrelevant. You could have it or you don't have to have it. Any other things you want to ask? Okay, so if they give you pictures, you got to be able to make equations for them. Here's another picture. Make me an equation. This one. Here's what I would have done. I would have started with y equals, because that's how all equations start. And then I go, oh, this is one of those kind that has a y-intercept and a slope of 1. So it's a y-intercept was -2 with a slope of 1, 1x minus 2. Okay, that's all good, except it doesn't have a hole yet. But do you get how I did it? I didn't even think about the hole until later. And then at the end, I put in a set of parentheses, and make sure you put this in parentheses then. That 1 in front of it really isn't necessary, right? And then the hole is at x is 3, so x minus 3 and x minus 3. Raise your hand if you had that one right. Okay, good. If you didn't, do you want to share what your mistake was? It helps me teach better. Yes? You knew there was a -2, and then you put it in front? Oh, on the way outside. I gotcha. I actually get what you're doing there. If you have this, it's just not. Then the x minus 3 wouldn't cancel right. That's all. But it's really close to right. Okay. Let's move on. I'm going to give you one more tough problem, and see if you can handle this one. If you can handle this one, you're going to be in great shape for tomorrow. All right. Y equals 2 times parentheses x squared minus 16. And then we're going to go x squared plus 5x plus 4. And I'd like you to tell me vertical asymptotes, horizontal asymptotes. Domain, hole, and we won't even graph this one. This is, if you can handle all these questions on it, you'll be fine. Okay. Now I guess I better give you a second. Okay, back recording again. Here are the answers. On the top, we should have factored that puppy to 2, and then an x plus 4 and an x minus 4. Don't talk, please. On the bottom, we should have factored it to x plus 4 and an x plus 1. Those cancel, and it's really, I'm telling you, it'll help you, especially in pre-calc next year, if you rewrite the function that you have left. Y equals 2x minus 4 over x plus 1. That's what I have left. Why is that important? Because when I find the whole, which, by the way, is this guy, it tells me negative 4 is important for the whole, but it doesn't tell me the whole thing. Oh, I never even thought of that. The whole thing. Anyway, it tells me part of it. Now I got to take this negative 4, stick it in here and here, and now I'll have 2 times negative 8 makes negative 16 over negative 4 plus 1 makes negative 3. Negatives cancel. 16 thirds. Raise your hand if you had that one right. Awesome. Domain. What makes this thing fail in this part now? Remember, I don't go back to the original one. The original one has a hole in it too. So, wait a minute. Was I doing vertical or domain? Okay, if I'm doing domain, then I should take anything that makes it fail into account. So, if I'm doing domain, I should look at this would make it fail, and so would that. So, domain is about the denominator. God, they both have D's. Maybe that will help you. So, all reals except x cannot be negative 4 and x cannot be negative 1, because those will make it fail, either as an asymptote or a whole. Next up, the horizontals. Bob will tell you about those. Is this one bigger on bottom, bigger on top, or same on both? Same on both, and therefore it's a ratio of the lead coefficients. There's nothing there. I'm going to put a 1. So it's y equals 2 over 1, which is y equals 2. And last one is the verticals. The verticals is not the whole, but the other thing that makes this have a problem is x equals negative 1. All right, so the verticals is also about the denominator. Yes, sir. It is same on both, yes. Nope, you got that confused. Bots, there's no bots. It's like robot, no bots. If it's bigger on top, there's none. I should write those rules out for you one more time. Bot, none. Same on both, y equals ratio. And if it's Bob, y equals outside. So Bob's an outsider, there's no bots, and same on both is a ratio. Okay? Yes? X plus 1. All right. What makes this part right here a problem is only if that's ever 0 on the bottom. That's what our problems are, is if we ever have a 0 on the bottom. Do you get how I could make this have a 0 on the bottom by putting in a number for x? So I'll give you a different one that's cleaner. Do you get how I could make this have a problem? If I put in a negative 4, I'll have a problem because I'll have something over 0. If you type it in your calculator, anything over 0, it'll say error if you can't handle it. So, did I tell you the cookies thing before? If I have 0 cookies and I divide it amongst 4 people, we just all get no cookies. Equals 0. But if I have, some of you will like this, if I have 4 people and I divide that by 0 cookies, we all get infinite cookies. Because 4 divided by 0 gets closer and closer to infinity. If you don't believe me, try 4 divided by this, and you'll get a really, really big number. So obviously then it's getting closer and closer to 0. It's getting closer and closer to an answer of infinity. I know that doesn't make any sense, but that's the point, is ones that are dividing by 0 don't make any sense. Do you know what I'm saying? It's a ridiculous example. Don't try to make sense of it. Yes. Ooh, forever is infinite. Okay, he said something kind of smart. I got to repeat this for the video. He said if you had 4 cookies and you leave them in the room with no people, then they'll stay there forever, which is like infinity. All right, I like it. Good thinking. There's no rats in infinite imaginary land. Okay.